This is Project Aspiration. This is week 1 of our progress. We would like to begin by stating that we are not engineers or scientists in any capacity, but mere high school students. Therefore, this video may contain information that is inaccurate and should not be taken for granted. This video contains a lot of images that do not belong to us, and we have tried our best to give credit where credit is due. This video serves only to show how we progressed with research and construction of the project. It all started with the landing of the Perseverance rover on 18th of February 2021. I recruited Nam to follow the landing live, and a couple of days later, he seemed so interested in the landing that he shared a document with me that described the details of creating another rover. When I looked at it, I initially thought that he wanted to build one, and so I began listing out ideas and materials we might need to build a rover. I found out the next day that he only shared the document with me because he wanted to design a rover, not to build it. But at this point, we were so interested in the idea of building a rover, we stuck with it anyways. We thought it might be fun.
Here's a photo of the Perseverance rover as it's tested. This is the basic form assumed by the post-built Opportunity rovers, including the Curiosity. It consists of 6 wheels, the front and back pails rotating by U-shaped brackets, high-torque drive motors attached to the wheels, a rocker bogie suspension system, which we'll get into the detail, the main body containing a plethora of scientific apparatus, all arrays of mass spectrometers, gas chromatographs, and typical leases request rock, and most recognizably the mass, holding the camera. The entire system is powered by a radioactive thermoelectric generator, OTG. We were uncertain about the configuration of the rover at first, bouncing ideas of it having 8 in-profile wheels or double-paired at the front that contain forklifts, but given the objectives of maximum traverse distance, decided on the typical 6x6 configuration.
This is our inventory and materials list. It contains everything we currently have or we need to get for our rover. On the left side is our inventory, which is all mostly parts that we can use to assemble. On the right side is the things we need to buy, which is mostly circuitry and little bits and bobs.
As the most critical components of a rover by allowing it movement, design of the wheels have been labored over by the JPL team and have also experience from prior rovers, mostly from the Curiosity. The basic structure of a wheel consists of the tread, machined from a single block of aluminum that is anodized black to prevent reflections, with chevron-shaped grousers, which are treads, a ring or multiple rings inside the rim to tighten it, adjust the stiffness, and the wheel center disc that is floated by flexure spokes titanium, and it serves both as landing gear to support the rover and driving gear. So it has to be very stiff but still have a certain degree of flexibility. Design review. The left image is first playing around with paper to see what sort of folds are achievable. The draft depth and gradations are there. Next is the cardstock strip, the first full-size prototype of the wheel. The lines were drawn out, scored diagonally, and then folded up to give the troughs and peaks, as seen on the right. The upper left shows the folded strip glued to a cylinder. On finding that the pattern could be easily flattened and knowing that it needs an inner sheath pressed against it, toothpicks were cut in half, were glued to the inner troughs, so hopefully it could remain somewhat rigid. On the left is the clover brim, designed to fit just inside the outer tread to maintain the shape. On the right is how it fits. Using external tooth lock washers, M12, I tried creating a wheel center assembly to attach to the inner rings. It consists pretty much of gluing toothpicks to the tooth with tacky glue. That result looks nice, but it's really weak because the plastic toothpicks have no flex past 15 degrees, and so it is at risk snapping off before you even contemplate how to glue it to the outer thread. You can see the left image is pretty much all the spokes are snapped off, which is my first attempt. Yeah, it's a work in progress.
The rocker boat system has different levers that keep the rover level while it travels over rock and uneven terrain. Initially, I was really confused trying to figure out how the rover balances on the single axis. I spent hours laying in bed trying to figure it out. Finally, I looked at some more images of the rover, and I realized that there's actually another piece called the differential bar that lies on top of the rover that gives it a third point of attachment. The, the axis that the wheels are attached to and the differential bar sit around the center of mass, so no matter what, the rover is always balanced on top of it. Our system will work similar to the actual one, with wheels attached to the rocker and the bogie. The rocker is a long beam with a single wheel attached to it, and the bogie is the rear part that is flat and has two wheels on it. For the construction of the rocker bogie system, we plan on using aluminum flat bars that are held together with washers and bolts. That way, it allows the pieces to move freely with each other. As far as the motors, we are planning on using step motors that so we can calculate the distance that each wheel is going to move and we can keep them all in unison. For the mainframe, we plan on using aluminum L brackets as it's sturdy and light, so the rover won't get crushed under its weight and it won't bend and twist as the rover moves. The brackets will form a box, which can have a lighter material covering it. We need to be careful of the aluminum frame and electronics, as it can short a circuit if exposed wires touch it. So far, we've spent $30 on three aluminum L bars, two aluminum flat bars, 16 machine screws, 100 nuts, 30 washers, and some black oxide drill bits. We are not sponsored by Home Depot, Everbuilt, or Ryobi. Perseverance Perseverance has 23 HD cameras, most of which are in color. But since they're very expensive, I only bought one and 2 megapixel camera that will be installed in the mast. The 2 megapixel camera has about resolution of 1080p. I'm still unsure how to transmit this data wirelessly, as I've never used any kind of I am still unsure how to transmit this data wirelessly, as I've never worked with any kind of wireless data transmitter before. We'll see how this goes. This is a mock-up of the camera NAND made from cardstock, just to get a feel for the size. There is a strange spacing in the lens, but this is only a mock-up and will later be finished. So far, it is made out of cardstock, and as for the bottom of the mast, we're thinking either making a cardstock cylinder or using a metal cylinder, whichever one will serve us better. Currently, this is the plan for circuitry. It's very messy and unorganized, but I'll make sense of it just a little bit. The whole thing is going to be run off an Elegoo. The whole thing is going to be run off an Arduino Mega R3, and will have an assortment of micro servos. I can't explain this reading what I write. Currently, this is the plan for the circuitry. It's very crude and messy, but I'll make sense of it in just a moment. The whole thing will be run off of a Mega Arduino, which has 53 ports, so we'll have enough space to incorporate everything. This will be run using step motors, as we can program it to move a specific distance. We might incorporate a robotic arm, depending on how this goes, that'll be run using microservos to move it. The mass cam will be ArduCam, which is 2 megapixels, and will be attached directly to the Arduino. Beneath it, we're going to be having a temperature and humidity sensor to give this some kind of scientific value. As far as powering this, we just have a simple 9-volt battery in its place. I don't think this is going to be enough power to run this for very long, so we might have to look for alternate power sources. I thought I had a cheap solar panel somewhere in my storage, so I'll have to look for that, see if maybe I can plug this into it. Lastly, we're going to need to transmit data and be able to send it data to move the rover, which I'm thinking RC is going to be the best option here.
This book has been serving as a Bible, The Design Engineer Curiosity by Emily Dr. Even though it's kind of expensive, just under $40, we were given 400 pages of exceedingly detailed view into the design engineering, yes, of the Curiosity rover, which is basically a 20 of perseverance and a bunch of insight into how development took place. There's no single book more ideal for us for our purposes. Think of watching possible live streams in the future with discussions between us. You should look at most.nasa.gov to find out more about rovers. Thank you.